In our study of the general properties of the Mercator projection, we noted that scale is correct at the equator,
and elsewhere expands as the secant of the latitude.
As we move away from the equator, the scale expands. This means that the same number of centimeters of chart length represents fewer nautical miles of Earth distance, and the denominator of the representative fraction decreases. The ATPL syllabus requires you to be able to carry out Mercator scale change calculations. These calculations divide into four main types of problem. They are: given scale at the equator, calculate Mercator scale at some other latitude. Given Mercator scale at some other latitude, calculate the scale at the equator. Given Mercator scale at some latitude, calculate the scale at some other latitude. And given a fixed chart length between meridians, calculate Mercator scale at a specific latitude. The basic Mercator scale change equation is scale at any latitude equals scale at the equator
times secant of the latitude.
Let's now apply this to the first type of problem. Given the scale at the equator, calculate Mercator scale at some other latitude. Our worked example is the simplest way. Here's example 1. If the scale of the Mercator chart is 1 to 1 million at the equator, what is the scale at 60 north or south? Start with the basic equation and then substitute into it what you know. The rest just drops out. So, scale at any latitude equals scale at the equator
times secant of the latitude.
So what do we know? We're trying to find the scale at 60 north. That's the unknown. Let's leave it on the left-hand side of the equation. Do we know scale at the equator? Yes, we do. It's given in the question. It's 1 to 1 million, so let's put it in. Now, what about the latitude? It's 60 north. Put it in. However, that's not a very convenient form for us.
Firstly, we don't have a secant function on our calculator.
And secondly, representative fractions always have 1 as the numerator. So instead, write it as 1 over cos. Your calculator will tell you that the cosine of 60 degrees is a half. So we've solved it. The scale at 60 north will be 1 to 500,000. To reassure yourself that you haven't got your algebra upside down, you should carry out a common sense check. The scale expands as we move away from the equator. This means that the denominator decreases. In this example, the scale was 1 to 1 million at the equator, and it is 1 to 500,000 at 60 north. Using the standard Mercator scale change equation, let's now see how to deal with the second type. Given Mercator scale at some other latitude, calculate the scale at the equator. Again, we'll use a worked example. This is example 2. If the scale of a Mercator chart at 52 degrees south is 1 to 2 million, what is the scale at the equator? Again, start with the basic equation. What do we know? We know the scale at 52 degrees south. It's given in the question. It's 1 to 2 million. And, as before,
we can put in the secant of the latitude. And again, write secant as 1 over cos.
Rearrange the equation to make the scale at the equator the subject. And remember from the lesson on basic scale, when evaluating a representative fraction, for easy calculator operation, divide the denominator by the numerator and then write the answer as 1 over the result. So 2 million over cos 52 is 3, 428, 538. So the required answer is 1 over 3, 428, 538. Again, do the common sense check. We have come up with an answer where the denominator at the equator, about 3.5 million, is larger than at 52 north, where it's 2 million. Does this make sense? Yes, it does. The denominator should reduce as latitude increases. It's the right way round. The next type is, given Mercator scale at some latitude, calculate the scale at some other latitude. Again, we'll use a worked example. This is example 3. On a Mercator chart, the scale at 54 south is 1 to 2 million. What is the scale at 25 north? We could solve this simply by combining the previous two methods, a double substitution. Knowing the scale at 54 south, we can find the scale at the equator. Then, knowing the scale at the equator, we can find the scale at 25 north. And it would work, but there is a quicker way. We can instead use this formula. Denominator at latitude A divided by denominator at latitude B equals cosine A over cosine B. The basic relationship is that scale at latitude A over scale at latitude B equals
secant A over secant B.
However, scale, or representative fraction, is 1 over denominator,
and secant is 1 over cos.
With a little rearrangement, we get denominator A over denominator B equals cos A over cos B. Initially, we'll solve the problem the first way, the double substitution. This is useful anyway, because it'll confirm that the denominator decreases as the latitude increases. Then we'll use the new equation, and this should demonstrate how much quicker it is. We'll start by finding the scale at the equator. Scale at any latitude equals scale at the equator times secant of the latitude. The scale at 54 north is 1 to 2 million. As before,
write secant as 1 over cos.
Rearrange to make the scale at the equator the subject of the equation. This gives us the scale at the equator. It's 1 to 3402,603, about 1 to 3.4 million. Now, knowing the scale at the equator, we can find the scale at 25 north. Go back to the basic Mercator scale change formula. Scale at any latitude equals scale at the equator
times secant of the latitude.
We know the equator scale, so we can substitute in for 25 north. Multiplying out gives us the scale at 25 north. It's about 1 to 3.1 million. We'll just check that our solution is sensible. Draw a little sketch showing the equator, 25 north and 54 north, which is the same scale as 54 south. Write in the 3 scales we found. At the equator, it was about 1 to 3.4 million. At 25 north, it was about 1 to 3.1 million. And at 54 south, it was 1 to 2 million. Again, we've got the denominators decreasing as we move away from the equator. It reassures us that we've got our algebra the right way round.